All right, so today we're going to talk a little bit about atomic structure and where to find information. And so one of the first things we need to do is we need to make sure that we talk about the periodic table. You might be thinking, wait a second, the periodic table is chemistry. And so if you haven't watched the intro yet to this section, this is the chemistry of life section. Biology and chemistry aren't actually separated. They work together. And so there are certain elements that actually make up 96% of life. Nitrogen is one of them, carbon is one of them, oxygen, phosphorus, sulfur, and hydrogen. And so those elements actually make up, like I said, 96% of life. So why the periodic table? What can we get from that? And one of the reasons I chose this periodic table is because it's interactive, which means when I click on one of the boxes, it does show it larger for you so you can see everything that we're looking at the element key. So this is called an element key. At the top of the element key shows you the atomic number. The atomic number is the identifier for a element. You have the element symbol, the element name, and then the bottom number is the atomic mass. When you look at these items, you can actually learn a lot about an element. Just from this information, we can get the number of protons, the number of neutrons, and the number of electrons. And then we can also map out and look at the number of valence electrons, or the electrons in the outermost ring of this element. After we do this, whenever you get to it, you're going to be doing this sheet right here that is understanding atomic structure. This is something you're going to make a copy of that you're going to stick into your biology folder. This is able to be interactive online, so when you see these here, if you decide to do them by hand, you can do them by hand and take a picture of it and also upload that to your folder, or you can double click here and you can actually draw right in here. So there's a scribble tool, so if you go to line and go down here to scribble, you can just free write. You can use the shapes in order to change it. You can use a text box to type into that. So I'm going to draw one on the board, but you can either do this online and then press save and close and it will save on yours. Or like I said, if you want to do it by hand. There's also a link in Moodle where you can print out this entire sheet if you want to. Take a scan of the entire sheet using your phone or using a scanner or whatever and uploading that into your Google folder. So here's this element key we just went over that you'll be again labeling on here. And then there's some practice here that you're going to do with finding protons, neutrons, and electrons. And then you'll be doing that with drawing and looking at a Lewis dot diagram as well. So we're going to go over an example. We're going to use oxygen to go over that as an example. And then we'll continue on. So if we talk about this information, so let's talk about how to do this. If I have oxygen, okay, and we know that the atomic number is what? At the top, what's the atomic number? 8. Okay, so the atomic number is 8. If we look at the rules, and again, if you didn't watch the first video, it's going to be a little bit difficult, but if you look at the rules, the first rule says that the atomic number also equals the number of protons. So for oxygen, and I'm using P plus because protons are positive, there's 8 protons in this atom. The second rule says that the number of protons equals the number of electrons. Kind of think that positive equals the negative in order to cancel them out so that the atom is neutral. So if there are 8 protons, there are also 8 electrons. The last one is the neutrons that we need the number of. Neutrons are neutral. They don't give a charge to the atom. They just simply give it mass. And so we figure that out from the atomic mass, or the mass number, minus the atomic number. So for neutrons, If you're looking at the number there, it's 15.99. You look at the number after the decimal point and you round as you typically would in math. So 5 and above, give it a shove. So this would then be 16. So for the neutrons, you would have 16, which is the mass number or the atomic mass, minus 8, because that's the atomic number. And you would wind up with 8 neutrons. So for this atom, they're all exactly the same. For some atoms, the number of neutrons will be different. So the number of protons will always equal the number of electrons, but the number of neutrons could be different. There is only one atom that has 0 neutrons, and that is hydrogen. If you get 0 for anything else, you did something incorrect. Go back and check. So now I have this information. So now let's draw this atom. So the first thing we want to do is draw a nucleus. Inside of the nucleus, we have protons and we have neutrons. So all I have to do for this is write the number of protons and write the number of neutrons. When you go to chemistry or in some other courses, they might have you actually draw the protons and neutrons, but we're going to do this shorthand, so you don't have to draw them all out. The only thing left that we have to deal with is the electrons. The electrons are outside in rings. So if we think about the atom, on the first ring, it's very small, it's very close to the nucleus, it can only hold a maximum of 2 electrons. I have at least 2, so I'm going to draw a 2 in there. But I still have some left. So I subtracted 2. So now I have 6 left. I don't want you to get confused later, but now I have 6 left that I have to draw. This second ring can hold up to 8. So I can just go ahead and draw in my 6. Now you'll notice that when I draw mine, I kind of position them like you're looking at a box. And I draw them at like the 12, the 3, the 6, and the 9. It doesn't really matter where they are, but I find that when you pair them together, 1, it's easier to count. 2, when you move over to the Lewis dot diagram, it's a lot easier. So the Lewis dot diagram essentially only shows the valence electrons, which are the electrons in the outermost ring. So all I have to do is write the symbol, and then I just draw the outermost ring electrons, or the valence electrons. So when I have it like this, again, I can kind of look at this like it's a box. And so I'm going to draw 2 at the top, 2 at the side, 1 on the bottom, 1 on the bottom. Your electrons don't have to be in exactly the same position as mine, but they should be on one of those planes. So you might have 2 here, and kind of arrange them around, but it kind of has to be on those planes. So for the example that I showed you, you're going to be doing this part, you're going to be doing this part, and you're going to be doing this part. There are a couple of examples. Then it's going to ask you some questions. And it's going to ask you some questions about whether or not an atom is going to bond. And so, if you watch the video, you should know that the magic number for the outermost ring is 8, except for the first one. So this atom does not have 8 in its outermost ring. So it wants to gain or get 2 more. If I was dealing with a smaller atom, like lithium, lithium only has 3, which means when I draw it, it says 3 protons and it actually has 4 neutrons. So I have 1 on the first, or 2 on the first ring, and 1 on the outer ring. It would take a lot more energy for this atom to get 7 more. But if it lost one, if it gave one away, then the innermost ring would be filled at 2. And so it's easier for it to lose them. The only other example would be when you have something that has a full outer ring. So it has 8. Or it's a small atom and only has 2. It no longer needs to bond. It doesn't need anything else. So it's not going to bond. So it's going to ask you a couple of questions about bonding. That's kind of a preview for what we're moving into on Tuesday. So for today, you should be here. You should be filling in that understanding atomic structure sheet and then be ready to talk a little bit about bonding on Tuesday.